Before we move on, we're actually going to do a quick section on graphing, and we're going to be doing a lot of graphing, especially early on in the year in geometry. So we're not going to kind of have a full review right now, but there are a few things I want to remind you of. And so this first slide, all we're going to do is we're going to kind of try to help paint a picture of when we're graphing a line, what actually are we doing? And this example we're going to use in actually the next few sections. You'll see it come up a few times here and then in solving systems of equations. But what we're going to do here is I want to use this equation to give you an idea of why we graph things. Okay, so there's a few things going on here, and what this equation is saying is that we have two unknowns that are two values, and those values actually could be anything. But the only stipulation that we have between these two values is that when we add them together, they equal 3. So right now, can you think of any values I could plug in for x and y that would make this equation 3? And the simplest example would be 3 and 0, right? If x is 3 and y is 0, then 3 plus 0 would in fact equal 3. And so for this equation, if we were graphing it, we can think of 3 and 0 as xy coordinates, right? So we would say that 3 comma 0 actually is a coordinate that would fulfill this equation, that when I add these two together, I equal 3. So let's graph that. So if each of these little boxes is 1, we'd start at 0, 0, and we'd go 3 in the x direction and then 0 in the y direction. So that would look like this: 1, 2, 3, right there. That's 3 in the x direction, 0 in the y direction. What's another pair? Can you think of another pair that we could order like this for x and y that would make this equation equal to 3? And you should be saying, well, what if we make x 0 and we make y 3? 0 plus 3 equals 3. That would work. And so 0, 3 is an ordered pair, an xy coordinate that would also work for this, that would also make this statement true. So we'd go 0 in the x direction, which is right here, and we'd go 3 in the y direction, so that is right there. And we could keep going like this. What if we did x equals 6 and y equals negative 3? Would that work? Yes, if this is 6, and y is negative 3, then 6 plus negative 3 would equal 3. So there's another one. So I would go 6 in the x direction, 1, 2, 3, 4, 5, 6, and then 3 in the negative 3 in the y direction, 1, 2, and 3. And you should start to see something forming. And the truth is that there are actually infinitely many pairs. I could keep going and I could keep coming up with these over and over and over again. There are infinitely many of these that would fulfill this equation. There isn't just one answer for what x and y can be together that would make this equation 3. There are actually infinitely many. And so these are how we represent 3 of them. Well, if there are infinitely many, then we represent that using a line. That this is what this line is. So I could actually draw a line through these 3 points, and I'm going to use this one right here. See if I can get this to work. Okay, and then what if I need to rotate it? Can I do that? Maybe. Okay, kind of. Let's get this in the right spot here. Okay, there we go. That looks good. What a line means, what this line means, and I'll fill it in with green so that you can see it a little bit better, is that every point that is on this line would technically fulfill this equation. That if I could pick any point on this line, and this is obviously a rough sketch, and when I plugged in, if I just picked arbitrarily, let's say this point right here, that looks like it should be on the line, even if it's not. And that looks like it's 1, 2, 3, 4, negative 4 in the x direction, and 1, 2, 3, 4, 5, 6, 7 in the y direction. Negative 4, 7 should fit in there. And so this is the physical representation of those infinitely many points that would fit into this equation and make this equal to 3. So that's what a line is. All a line is just the every single, a visual of every single x and y coordinate that would make an equation true, like this one. And there's a standard form for those equations, and that, of course, is the slope-intercept form. And the slope-intercept form for a line is y equals mx plus b. And it's important to remember here that x and y are those points. What x and y represent here, even in this slope-intercept form, are all of the different points that will make this eventual equation true. Remember, m is the slope, which is rise over run. And b is the y-intercept. And I'm just going to write y dash int. And that stands for y-intercept. And what that means is where this line crosses the y-axis. So where does this line cross the y-axis? Clearly this line crosses the y-axis at 3. So here the y-intercept would be 3. What would the slope be? Well, the slope would be rise over run. Between each point, I have to go down 1 over 1, down 1 over 1, down 1 over 1. And so when I'm going down 1, that's the same. My rise would be, when I'm going down 1, negative 1. And my run is to the right, so that's positive 1. So my slope overall in this line is negative 1. So the equation of my line, if I rewrote that, would actually be y equals rise over run negative 1 times x plus, and what do we say our y-intercept was? Our y-intercept was 3. Okay, and so this would be the equation of this line if we put it in slope-intercept form. Now we got this just by looking at the line, but also look at this. Up here, if I just solved this equation for y and got y by itself, what would I get? Well, I would have to subtract x from both sides, and when I do that, I would get y equals negative x plus 3. And that's not an accident that these two equations are the same. That is because they are the exact same. Those are both equations of this line in slope-intercept form. So this is supposed to be just a quick refresher. What we're going to do now is we're going to do some examples. If we were to graph each of these lines, we're going to do that together. So here, our slope is 1 over 2, and our y-intercept is negative 3. So I'm going to start with my y-intercept. So I'm going to go find y equals negative 3, which is right here, and that's where this line is going to cross the y-axis. And then my slope is rise over 1, 1 over 2. So I need to rise 1, go over 2. Rise 1, go over 2. And when I have 3 points, let's try and draw this. It's going to be difficult. Not too bad. I can actually draw that line, and this is what this line looks like. A line with a y-intercept of negative 3 and a slope of 1 over 2. And remember, what these all are, these really are, this line is actually just a bunch of points that I could fit into this equation that would make it true. They're a bunch of x, y coordinates. Let's go to this line now. Y equals negative 4/3 x plus 1. Okay, where positive 1 is the y-intercept. That's where this graph crosses the y-axis. So that's right there, positive 1. And then I need to go, this negative can either go to the rise or the run, but it can't go to both. So let's just say that it's going to go to the rise. So I need to rise negative 4. In other words, I need to go down 4. 1, 2, 3, 4. And then I need to go over 3. I'm running 3. So 1, 2, 3. And now I'm going to come back to our original point. I'm actually going to send the negative sign down to the denominator here. And so I'm going to go up 4. 1, 2, 3, 4, because the 4 is now positive. And then I'm going to run in the negative 3 in the x direction. So that would be 1, 2, and 3. Okay? And then we have the graph of this line right here. Okay? So that is graphing this line with using slope-intercept form. Now, what happens when we have an equation that's not immediately in y-intercept form like this one here? Well, we'll have to do some work, and how to get it in slope-intercept form is we need to solve this for y. So we need to get this y by itself. So the first thing we need to do is get any terms that don't involve a y off that side. Well, this 2x doesn't have a y in it, so we're going to subtract 2x from both sides. Okay, and then see where we're left. Okay, so what will be left on this side of the equation will be negative 3y equals negative 2x, because we subtracted it, plus 12. Okay, and then the y is still not by itself. We still have some work to do, so we need to divide both sides by negative 3. And then what we get is, over here, those cross out, and we get y equals, this is negative 2 divided by negative 3 is 2/3, positive 2/3, and negative divided by negative is a positive, times x. And then 12 divided by negative 3 is negative 4. So 2/3 x minus 4. So sometimes you'll have to do some work to get the line into slope-intercept form before you can graph it. But now that we have it graphed, we can actually take a look at this. And the y-intercept is negative 4, so I need to plot that point there. And then let's take a second to look at the slope. The slope is rise over run, so I need to start at my original point, y equals negative 4. I need to rise 2, go up 2 in the y direction, and then run 3, go to the right in the x direction since it's positive. So I'm going to go up 2. Now my mouse doesn't want to work. I'm going to go up 2, 1, 2, and then I'm going to go over 3, 1, 2, 3, and I'm going to plot this point. So there's one of my points. And then I'm going to do the same thing again. I'm going to go up to 1, 2, and then I'm going to run 3. 1, 2, 3. There are my 3 points, and there is my line. Okay? And then we need to talk about a couple of special cases. What about these types of lines where y equals 4 and where x equals negative 3? What this is saying is I want to draw a line where in every instance, every point on the line, y equals 4. Okay, so I'm going to go where y equals 4, and I have a lot of students that often get this wrong. It's hard to remember which way you want to draw this line, but just think about it like this. If I pick any point on the line that I draw and y is not 4, then I'm not meeting the requirements of this equation. Y has to equal 4 on every point. So if I were to draw this line right there, actually I'll draw it in red, sorry, so that I'm consistent with my colors here. If I were to draw this point right here, this line, now you see how the x value changes every time. If I pick this point, the x is different than right here, and then the x is different than right here. This time, right over here, x is negative 5, but right here, this point on the line, it's 2. But if you look at it, at every point on this line, y is always 4. There's never a point on this line where y is not 4. So this is the line y equals 4, and that's how you can think of it. After you draw your line, you need to look at it and you need to say, okay, well, is y 4 at every point on this line? For this one, it is yes. If I were to draw the opposite, if I were to draw it this way accidentally, you could see that the x value is not changing, but the y is changing every time, so you would be violating this equation. Okay, so let's look at, then in that case, x equals negative 3. Well, let's go to where x is negative 3 right here. And then I need to draw a line such that at every point on this line, x is always negative 3. So I'm going to draw this line, and I'm going to take a second. I'm going to look. Okay, if I pick points on this line, like this one right here, is x negative 3? Yes, it is. If I pick this point right here, is x negative 3? Yes, it is. So all the points on this line are negative 3, which is what makes this x equals negative 3. Now, so you can do it that way, where you can go back and check and make sure that your line meets this equation. But another way, you could just memorize that when it's y equals, then I'm going to draw a horizontal line. And when it's an x equals some number line, I'm going to be drawing a vertical line. So there are multiple ways of remembering how to do this. But that's graphing. Kind of nice, quick review of graphing. The big things you need to remember are slope-intercept form. You need to remember that this is the y-intercept b, that m is the slope, and then you need to remember how to graph the slope. So what I'm going to do is we're going to get lots of practice with this. I want you to go ahead to the last page in your notes. I want you to go ahead and graph each of these on your own. So the first thing you're going to need to do, I'll give you kind of a preview, is you need to get them in y equals mx plus b form. Neither of these are in slope-intercept form right now. So you need to solve both of these equations to get y by itself, and then you can begin to solve from there. Okay, so do that, and then we will begin to practice.